Okay, this is part 4 of, I can't really call it a series, but yeah, this is my review for my second quarter exam for physics. This is grade 12 physics in our school. So back to where we are, you cannot cancel the minute and second units. So you have to convert minutes to seconds, which you have already done. It's 180 seconds. So cancel the second unit, and we have 180 times 6. So 180 times 5 is 900, and then plus 180, that's 1080. As you can see, the answer is already here, but yeah, we found the same answer anyways. So let's move on. How many seconds will it take for a satellite to travel 450 kilometers rate? So we have to look for the time. We have 450 kilometers, so we have to convert this into meters. So 450 km to meter in the unit, what do you call this? Basically, we have kilometer here, HM, hectometer, decameter, and meter. So the distance between kilometer to meter is 3 zeros. So just add 3 zeros. So this is 450,000 meters, and the rate is 120 meter per second. Oops, sorry about that. We have to search for the time. So D is equal to RT, or let's just use this. Essentially, both formulas that I'll be writing are the same thing, but the only difference is V and abbreviated as V, and rate abbreviated as R. But V and R are the same thing in our context. So but algebraic manipulation, time is equal to distance over velocity. We have 450,000 meters over 1. We divide that by velocity, which is 120 meters per second. And if you want to remove the divide sign, the oldest trick in the book, we have to reciprocate. So seconds here, and then 120 meters here, so that the unit meter will cancel. So time is equal to, well, the only challenging part here is the simplification of 120 and 450,000. So 120, 12, 24, 36, 360, 900, 900, 60, 74, 7, 84, 600, 5, 375. Wait, I'm supposed to use the calculator so that it would be faster, but just in case you're not allowed to use the calculator, you just have to try really hard. Well, I was one step away. There had to be another 0 at the end. Anyways, I've just taken the De La Salle college entrance exam, so yeah, everything has to be mentally computed. So next, a ball rolls down a ramp for 15 seconds. If the initial velocity of the ball was 0.8, okay, so we have VI 0.8 meter per second, and the final velocity was 7 meter per second. What was the acceleration of the ball? Okay, so this is where the acceleration formula comes in handy. Again, it's VF minus VI divided by the total time. The total time is said to be 15 seconds. Okay, so we have everything that we need. Let's start substituting the values in the formula. In my professor's physics quizzes and exams, everything that's basically graded, we have to write something like this. So this is the given. This is the, well, required is the acceleration. And we have the formula, or the equation. And then we have the solution and then the answer. So solution, we have 0.8 meter per second minus, wait, we have to write it the other way around. Vf is 7, so Vi is then 0.8. And then time total, we have 15 seconds. 7 minus 0.8, that's 6.2. 6.2, 62 over 150. This is meter per second in the numerator. And denominator is seconds. This has to be somewhere 0.4 something. Anyways, I tried to mentally solve it again, but we ought to use the calculator. So yeah, my estimate is pretty okay. It's 0.4133. It's a non-terminating decimal. Let's just write 0.41. And then because this is acceleration, we don't cancel any units. Actually, it becomes something like this. So meter per second squared. So this is the answer. Well, yes. I just had to write another 3. And we have exactly the same answer as what is written here. So, next, a ball is rolled at a velocity of 12 meters per second. After 36 seconds, it comes to a stop. What is the acceleration of the ball? So, we are given an initial velocity. So this is what we started with. And after the time ends, it is said to come to a stop. So we're not given any final velocity, but if you think about it, if something, an object, particularly a ball in our scenario, if it comes to a stop, then the final velocity or the velocity at the end of the journey will always be 0. So in this case, we have to write the formula again. We are looking for the acceleration. You may already see the answer, but that's all for it. The way our teacher grades us is not for having the right answer, but for having the right solution, as well as writing the given, the equation needed, the solution, all of that. And also don't forget to write the units. They're very crucial. So the acceleration is Vf minus Vi over time total. Vf is 0 meters per second and Vi is 12 meters per second. Time total is 36 seconds. Negative 12 over 36, negative 1 over 3. Negative 1 over 3 in decimal form is negative 0.33. And because this is acceleration, just know that the unit will be meter per second squared. So we now have the acceleration. Yeah, exactly. We exactly have the same value as the correct answer. So what is the distance if a train will stop in its initial velocity of 23 meters per second? Its acceleration value is given, so it's negative 0.25 meters per second squared. Well, by the way, I have to say this. The ball had a value in terms of its initial velocity, and it eventually came to a stop. During its stop, its potential energy is at its maximum, kinetic at its lowest. The acceleration of the ball, basically, the reason why the value is negative is because it was decelerating. I mentioned this in the previous videos. Unfortunately, I had to cut short. I couldn't really finish everything in a single video due to personal reasons. I'm still pretty busy at this point, but yeah, I'm still making a video documenting what I know from school. Uh, so we're looking for the distance if a train stops. So VF is going to be 0 meters per second. Distance is missing. We're not given any time, so I can't really say if this is going to be more challenging. Okay. Let's see if we could let's see if we can solve this way. So acceleration is negative 0.25 meters per second squared. VF is 0. VI 23. Time is missing. Okay, the negative signs cancel. We have 23 over 0.25. That is 92. And then, if you think about it, meters per second, that's their unit in the numerator. Denominator, we have something like this. If you cancel, you are left with the unit second. So, time that it takes for this entire journey is 92. Well, that's not our final answer yet. You have to look for the distance. We'll use the good old velocity formula. So velocity is equal to distance divided by time, such that the time that we have is already the time total. So we don't need the time final and a time initial. But in the numerator, well, actually, this is what we're supposed to look for. The distance, the total distance. And we're given a velocity. So let's try the initial velocity, 23 meters per second, and the distance is missing. Total time traveled was 92 seconds. Multiply both sides by 92. 92 times 23. I won't mentally solve that anymore, but 92 times 23 is said to be, well, 2116. Something's wrong. Feel free to skip this part. I'll just figure out what's wrong. I hope I've solved this kind of problem back then. Let's see. Biology, physics. Found it. We actually have a formula that is exclusive for looking for the distance. I forgot. A while ago, I told you about the 5 kinematic formulas. We have to use either this or this. So in our situation, we are given VFVI and the acceleration. So yeah, we won't use this. we're not given a time value. Vf is 0 meters per second, and put a squared. Vi is 23. Acceleration is negative 0.25. According to the calculator, the value is 1058. And then put the meters. So what distance will the car cover accelerating from? So distance is missing. So Vi is 12 meters per second. Vf is 26 meters per second. Time is 14 seconds. So we're not given an acceleration value, but we can use the formula that was mentioned in the latter part. So d is equal to Vit plus at raised to 2 over 2. So furthermore, we have 12 meters per second times time, which is 14 seconds, plus the acceleration. We have to look for acceleration. We have to. So acceleration, we have Vf minus Vi over t total. Vf is 26 meters per second. Vi is 12 meters per second. Time is 14 seconds. So we have 14 over 14, that's 1. Interesting. Acceleration is a clean number. Okay. Let's see if I can also solve using the other formula. Yeah, I have to keep remembering. This is plus, this is minus. If I interchange any of those formulas, then I'm extra dead. Anyways, acceleration is 1 meters per second squared. Time is 14. We divided by 2. 144 plus 24. 168. Am I correct? I got it right. Okay. So distance is in meters. 14 divided by 2, that's 7. Wait a minute. 14 raised to 2 is 196. 196 divided by 2 is 98. And don't forget the meters. We have 267 meters for the distance. Let's see if we can solve using the other formula. Okay, Vf is 26 meters per second, and then Vi is 12 meters per second. 2a, acceleration is missing. We found it already. So meters per second squared. 26 raised to 2 is 676 minus 12. Don't forget the unit. 144. And then we have 2 meters per second squared. 676 minus 144 is 532. Divided by 2, we have 266. And then cancel the values. Second squared and 1 meter will cancel out, so we remain with the other meter, since those 2 meters construct a raised to 2. Okay, number 3, a person, wait, for what? We have 266 meters as the answer. This is more accurate, but either way, we found a really close answer using the other formula. So a person starts at rest, VI is 0, and then accelerates at 3.2 meters per second squared for the time of 3 seconds. So VF is missing. What is the average velocity? And what is the distance that they would cover in that time? Alright, so first things first, let's solve for the VF. I think that's the easiest that we could solve right now. VF is, well, let's use the acceleration formula. VF minus VI over time total. Acceleration is equal to VF. VF is missing. Acceleration is 3.2 meters per second squared. VI is 0 meters per second. Time total is 3 seconds. VF is equal to 9.6, I believe. Is it 9.6? 3.2 times 3 is, yeah, it's 9.6. And then the unit for VF is going to be in meters per second. Okay, we now have the value for final velocity. Let's solve for the average velocity now that we have VF. Average velocity is basically VF plus VI divided by 2. VF is 9.6 meters per second. VI is 0 meters per second divided by 2. 4.3, I suppose. Is it 4.3? Let's see. 4.8, actually. Damn. That is my first time to make a mistake. Today, of course. The previous days are different. I might make a video teaching about Poisson hypergeometric binomial distribution, as well as calculating for molarity and molality, and molar mass, of course, and the using of Avogadro's number. I just realized that those topics are my favorite since they're really challenging. Of course, I'll just teach what I know, the basics. Anyways, so what is the distance? So what kind of formula do we have for distance? Distance is equal to VIT plus AT raised to 2 over 2. Or we could use the other one. Technically, we have acceleration as well as the initial velocity and the time. So even if we didn't solve for final velocity, we could still look for the distance. So let's use this. The reason is, well, I just wanted to use it. So VI is 0 meters per second. Time is 3 seconds. Acceleration is 3.2 meters per second squared times the time, which is 3 seconds. And then don't forget to raise to 2 and then divided by 2. So 9 times 3.2, I think that's 27.6, 28.2. 9.6. Wait. Sorry. 28.8. Kind of far from my estimate, but Anyways, 28.8 divided by 2 is 14.4. So the distance is 14.4 meters. Okay, number 4. A car is going 12.7 meters per second. And then it accelerates for 14 seconds. Okay, so this is the initial velocity for the reason that from there, it starts to accelerate for 14 seconds. So 14 seconds is going to be the total journey, like in terms of time. And the acceleration value is given, so 2.6 meters per second squared. So the final velocity is missing. Okay, so what distance does it go during that time? Acceleration is equal to Vf minus Vi over t. Acceleration is 2.6. Vf is 12.7. Well, sorry, Vf is missing. That's what we're looking for. Vi is 12.7, and the denominator is going to be 14. So 14 times 2.6 is going to be 36.4 meters per second. And yeah, just transpose 12.7 to the other side. You find the sum of 36.4 and what was transposed, 12.7, you get 49.1. Wait a minute. Sorry, something's wrong. So 36.4 meters per second squared is added with 12.7 meters per second. The Vf is said to be 49.1. Of course, the unit for final velocity is in meters per second, just the same as Vi. But what I'm concerned about is this. The unit for acceleration, can it possibly merge with the unit for something that's not acceleration? The units are similar, but then for acceleration, we have a raised to 2 in the seconds or in the denominator. So I'm just wondering if that's okay. We got the correct answer anyways, but yeah, that might be a concern. Anyways, let's solve for the distance. To play it safe, let's use the VIT thingy. So distance is equal to Vi. Vi is 12.7 meters per second. Time is 14 seconds. Acceleration is 2.6 meters per second squared times the time, which is 14 seconds squared. 14 seconds and then put a squared and divided by 2. Solve. 12.7. If I mentally solve this, 12.5 times 14. Never mind, it's too hard for the time given. It was never my intention to make my videos really long, but yeah, can't help it. I want to explain properly and yeah, just take my time. Divided by 2, 254.8 plus 177.8, that is 432.6 meters. So yes, we got it right. Let's go to number 5. many questions do we still have? That is a lot. What time will it take you to hit the water off a 10-meter board? Okay, I suppose this is the distance. What speed will you be going when you hit the water? So when you hit the water, that's final velocity. I believe that's the missing value. Well, before that, you have to look for the seconds. What time will it take you to hit the water? Okay. I believe the initial velocity is implied to be 0. We're not exactly given a value, but if you think about it, jumping from a board, you start with a velocity that's 0. Usually. This is nothing too complicated. Although yes, realistically, the swimmer will jump, so that's something to calculate. But yeah, that's a more specific kind of physics. Right now, we're just trying to solve the basics. So distance is equal to VI T. We don't have acceleration. Nope, this isn't going to cut it. I'll have to review this. Let's just see the answer. Number 5. It's not here. I'm not sure if the board is supposed to be like the platform where you jump all the way down, or maybe it's the height of where you're jumping from. What speed will you be going when you hit the water? Let's summon all of the kinematics formulas and figure it out. I have an idea. Choosing from the formulas, we could utilize df is equal to vf raised to 2 minus vi raised to 2 divided by 2a. We have the distance. Well, shoot. We need So final velocity. Let's try the VIT formula. VIT plus... Damn. We don't have the acceleration. That's the thing. VF minus VI. I can't believe I don't have notes for that. I was pretty sure I had everything. Ah, screw it. Let's study this later. It's gonna take a lot more time. Let's move to number 6. A car slows from 42 to 21 over a distance of 84. So we're looking for the average velocity, the time, and the acceleration. Okay, so average velocity is equal to VF plus VI over 2. VF is 21 meters per second. VI is 42. 21 plus 42, that's 63. 63 divided by 2 is 31.5. Double check. Nice. So it's 31.5 meters per second. Oops. Whoa, what just happened? Oh, okay. Never mind. Okay. What was the time? Time total is equal to, well, what are the formulas? We do have distance, but acceleration is missing. Let's calculate for the acceleration first. So acceleration is VF minus VI over 2A. Sorry, over time total. VF is 21 meters per second. VI is 42. Time is missing. Oh shoot. Okay. We don't have the time. So Let's use this formula. Distance is equal to Vf raised to 2 minus Vi raised to 2 divided by 2a. Distance is equal to Vf. Vf is 21. Vi is 42. 2 times the acceleration. Acceleration is missing such that distance is already given. So, 21 raised to 2 minus 42 raised to 2 is equal to negative 1323 meters squared seconds squared divided by 2a, and then we have 84 meters here. 84 times 2 is 168. Oh, don't forget the a. And then divided by, equal to negative 1323 meters squared over seconds squared. We have to ration the space that we have. It's a digital notebook, but we still have insufficient space. Okay, 1323 divided by 168, that is 7.875. Don't forget the negative sign. One is negative, one is positive. Either multiply, divide, the answer is always going to be a negative value. And what happens with the unit? We know that acceleration is meters per second squared. So apparently, the meter squared and the meter here should cancel. We are left with the unit meter per second squared, henceforth. Fancy word, but yeah. That's for acceleration. Let's solve for the time. Time is equal, let's use d is equal to VIT plus AT raised to 2 over 2, such that VI is 42. Distance is equal to 84 meters. We don't really have much space. This is so insulting. We have to adjust. Acceleration is, let's just write A. No. Acceleration is already found. Time is missing. Divided by 2. By the way, what is... Yeah, we have to look for time. Multiply both sides by 2. That's what I suggest. So 84, 168. 42, 84. Make this a minus. Factor out. Well, no. We can't really factor out at this point. Square root, perhaps? This is so weird. I'm thinking of solving using the quadratic formula or factoring, but that's just so weird. Yeah, I think it's best to um, place everything under quadratic. Sorry, under a radical sign. So 168, that's 1384. No, 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 no. Let's not use that formula. Let's use acceleration equal to Vf minus Vi over time total. Besides, we have the acceleration anyways. Why did we use the hard formula? Vf is, well, 21 meters per second. Vi is 42 meters per second. Time total is missing. 21 minus 42, well, negative 21. And switch the positions. We have the acceleration here in the denominator. In exchange, the time total is here. (21) over 7.875 is 2.67. And then it's time, so the unit is in seconds. Boom, we got it. Let's move on to number 7. A car skids to a halt, so final velocity upon halting is 0. Distance throughout the entire deceleration is 34. I wonder why the acceleration is negative. I thought the car was supposed to skid to a halt. Or maybe you didn't have to write the negative sign anymore. Who knows? I suppose that's for you to research. Let's find the initial velocity. Okay. Acceleration is equal to Vf minus Vi over time. Time is missing. We don't have the time either, so perhaps not this. Distance is equal to Vf minus Vi over 2a. I think this is better to use. We have 34 meters. Vf is 0 meters per second. Vi is, well, the same thing. 2a, 2 times 8.2, 16.4 meters per second squared. Multiply both sides by 16.4. 34 times 16.4 is equal to 557.6 meters squared over second squared. No, that's not possible. Shoot. What do we do with the negative value? It's not possible for... This is an imaginary number, actually. If you try to put any x value with a negative sign and it's inside the radical sign, the answer will be a math error. But then realistically, we don't know what Vi is. Most likely it's going to be a value more than 0. Of course, the car is still moving before it starts to skid to a halt. Let's just disregard the negative sign. we have everything else anyways. We all know that the squared in the units can be liberated in a way that in the end we're gonna have meters per second. And if you look for the square root of 557.6, you get 23.6. Exactly the same as what we have as an answer before we even solved it. So, number 8, what is the acceleration of a train in order for it to stop? So, it's a deceleration. We already have the final answer, which proves the idea that it's decelerating since the value is negative. So initial velocity is 12 meters per second. Distance is equal to 541 meters. Acceleration is missing. Well, final velocity, by the time it stops, the train stops, it's going to be 0. So acceleration is equal to Vf minus Vi over 2a. Sorry, distance. Yeah, this formula is the one we have to use. Distance is 541 meters. Vf is 0 meters per second squared minus Vi is 12 meters per second squared over 2, and then we have a 2a. 2a multiplied both sides, 541 times 2 is 1082. You have negative 144 meters squared second squared. Okay, negative 144 over 1082. That's going to be negative 0.13. And then because this is acceleration, the unit is going to be meters per second squared. We have the answer. Next. Okay, so this is going to be more in free fall. So coin was dropped from the top of the tower, and it takes 1.85 seconds to hit the ground. So yeah, a coin from above goes down. And yeah, in our case, we don't have something like this. There's no projectile in a way. We're just trying to drop a coin. So the time total is basically equal to the time going down, which is 1.85 seconds. Why did I, in the first place, talk about... I somehow implied that there is a difference between time going down and time total. Well, in the context of projectiles, we divide, in terms of time, we divide both sides by 2. So this is the going up, time going up, and then the time going down. So yeah, time total and time going down isn't exactly equal in all scenarios. Only in the scenario of an object going down, the time total is equal to the time going down. So what is the velocity in meters per second after 1.10 seconds of free fall? So this is the total, and this is the... You just want to know, for example, this is the point where it's the object is 1.10 seconds after falling, and yeah, we also have to calculate for the final velocity by the moment the coin impacts the ground, or before the coin hits the ground. So shoot, it's been a long time since I've solved these kinds of problems. Well, there is no force in terms of going down. So falling, the VI is supposed to be 0 meters per second. There was no mention of any force, for instance, like forcing the coin to fall in a way. So yeah. Uh, we don't have the distance. Let's see my notes. Okay. We will be utilizing these formulas. Uh, as you can see, instead of writing A, we have G instead. G is basically for gravitational acceleration. It's a constant. It's approximately 9.8 meters per second squared. We're dealing with gravity at all times. So yeah, even if we're not given a value of acceleration, we already know that G is always equal to 9.8 meters per second squared. We're on Earth, so this is the constant. That constant varies depending on how strong the gravity of that planet is. In Mars, it's theoretically a lot, well, not really a lot, but significantly lighter or weaker in a way. You have to know this. If gravitational acceleration, if your object is going down or falling, then it's positive. If you're trying to, say, shoot a bullet upwards, then the gravitational acceleration is a negative value. It's the same value, but the sign is negative. That's one thing you also want to know. You would also want to know. The time total is 1.85 seconds. Gravitational acceleration is 9.8 meters per second squared. VF is missing. What's our VI? It's 0 meters per second squared. Okay, so this is the second missing value. We have to calculate the velocity at impact in meters per second. So upon impact, the time is going to be 1.85. So multiply both sides by 1.85. 9.8 times 1.85 is equal to what? 18.13. Then square root. The answer is equal to 4.26. meters per second. Let's see if we got it right. But before that, let's calculate for the velocity after 1.10 seconds instead of the time total. So I believe we could use the same formula. So 9.8 meters per second squared equal to Vf raised to 2 minus Vi, which is the same, 0. And then the time this time is going to be 1.10 seconds. So 9.8 times 1.10 is equal to 10.78. And then we have Vf here. So what is the square root? According to the calculator, Vf is then equal to 3.28 meters per second. As you can see, if you may observe, the final velocity for upon impact is higher compared to the final velocity if the time is not done yet. So yeah, that's naturally true, since the kinetic energy is at its maximum before it hits the ground, like the very moment before it starts to hit the ground, before potential energy takes over again in its maximum value. The velocity before it starts to hit the ground is at its highest before it goes to 0 again. And so yes, I'm not sure if that's properly explained, but yeah, I hope you understand what I mean. Let's see if it's correct. Sheesh. It's wrong, I think. There's something wrong with the formulas. I think that's what's up. You know what? This is getting so annoying. Okay. Instead of the formula being this, we were accustomed to... Oh, I see. There's something wrong with our formula. This is supposed to be the formula. Sheesh, you have to do everything all over again. Well, not exactly all over again, but you just remove this, the raised to 2. So 1.85 times 9.8, that's going to be 18.13. The seconds will cancel out. And yeah, this is the final answer. And what's the other one? Remove the raised to 2. 9.8 times 1.1. That is going to be 10.78 meters per second. I believe that's the final answer already. Yes. Okay, problem solved. Let's move to the next one. Before that, let's see how much more questions we have to answer. Okay, I might stop here for a while. I'll continue in a few minutes. Part 5, I guess, is the next video. Thanks for watching.